Assalamualaikum warahmatullahi wabarakatuh and good evening. So we will continue our class on the Fourier series. So in the last class we have discussed about the Fourier series of a even function. So before we continue with our next example, let's recap what we have learned so far in the last class. So in the Fourier series of even function, first is in order to identify a Fourier series or identify a even function, so you must sketch a graph. So given a piecewise function, what you need to do is first you sketch a graph, and then from the graph you determine whether it is even function or whether it is odd function or neither function. So for even function, you must make sure that the graph is symmetry on y-axis. So if the graph is symmetry on y-axis, then you can proceed finding a Fourier series for even function. So Fourier series for even function, given the formula, you need to find a naught, where a naught is 2 over L, integration from 0 to L fx dx, and an is 2 over L, integration from 0 to L fx cos n pi x over L dx, while bn equal to 0. So this is the Fourier series for even function, and then you will write the Fourier series as a naught over 2 summation from n equal to 1 to infinity an cos n pi x over L. So this is all the procedures that you need to do in order to find a Fourier series for even function. So in this class for tonight, we will finish an example for Fourier series of even function, and then we will continue with the last subtopic, which is Fourier series of odd function. Right, let's see this example. So a periodic function fx is given as this function, piecewise function. So we have fx equal to 2 in the range of -2 to -1. It is equal to 0 in the range of -1 to 1, and it is equal to 2 in the range of 1 to 2. Given how you know this is a periodic function, so it is a periodic function if we are given a periodic. The function of fx equal to the function of x plus 4. That means after the period equal to 4, it will equal to this fx again. So the question is, if fx is an even function, so it's already tell you this is a even function. Find Fourier series coefficient. So Fourier series coefficient, what you need to find is a naught and also an. Do you need to sketch the graph? No, you no need to sketch a graph because it does not tell you to sketch the graph. And guess what function is? It already tell you this is even function. So for any given function, even function, so you just substitute this formula. So use this formula only to substitute to get a Fourier series. And then write the corresponding Fourier series of fx. So let's do this example. So first, let me copy this one. So copy first. Ada soalan ke? Siti Nur Faiza. Looks like ada yang angkat tangan tu. Ada? Tak ada. Tak sengaja. Alright. Okay, so the question asks, this is a even function. So for even function, you need to have a naught and an. So before we proceed to find a naught and an, let's define L. So from this equation, 2L equal to 4. So you know L from this one. So we have 2L equal to 4. So L equal to 4 divided by 2. So 4 divided by 2 is 2. So find the value of A naught. So A naught is given as 2 over L from 0 to L fx dx. Integration of fx dx. Because this is piecewise function, we are going to integrate from 0 to L. So you look the range. Here the range is from -2 to -1. Here is the range from -1 to 0. And here is from 1 to 2. So we are going to integrate from 0 to L. So we need to integrate from 2 divided by L. L is 2. So from 0 to 2 of function fx. So look in the piecewise function. So where is the range of 0? From 0. So you look here. So 0 contained in this range. Because this range is start from -1 to 1. That means if I want to integrate from 0, I need to use fx. This one. So fx. So this one should be from, sorry. So 2 divided by 2 is 1. 1 multiply integration from 0 to 1. Here, 0 in this range. So this range up to the x equal to 1. So that means 0 to 1. What is the fx? Fx is 0. So 0 dx. And then we want to integrate from 0 to 2. So lastly, the range of 0 to 1 to 2 is here. So equal to 2. So 1 to 2, 2 dx. So integration of 0 is 0. Integration of 2, you get 2x. So 2, you get 2x from 1 to 2. So you substitute 2 multiply 2 minus 2 multiply 1. So 4 minus 2 equal to 2. So our A naught now is 2. Next, we want to find N, AN. So AN is given by 2 over L from 0 to L fx cos n pi x over L dx. So L is 2. So 2 divided by 2, 0 to L. L is 2. Fx cos n pi x over L. L is 2 dx. So let's put this one in bracket. Alright, so from the piecewise functions, we have defined. So 2 divided by 2 is 1. So from 0 to 1, 0 cos n pi x over 2 dx plus from 1 to 2, 2 cos n pi x over 2 dx. So you look in the piecewise function here from 0 to 1, our fx is 0. From 1 to 2, our fx is 2. So we got this one. Alright. So 0 multiply cos n pi x. So this one should be 0. So I just cross this one. Hence, I need to integrate 2 cos n pi x. So 2 I can put outside. So just integration from 1 to 2 cos n pi x over 2 dx. So we want to integrate cos. So integration of cos is sine. So 2 integration of cos is sine n pi x over 2 divided by derivative of n pi x, which is 2 over n pi. Or this one I should write as 2 over n pi. From 1 to 2. Okay, notice that 2 over n pi is just a constant, no x in this constant, in this coefficient. So I can pull this outside. So I put this one outside. So I have 4 over n pi. So here I have sine n pi x over 2 from 1 to 2. Now substitute x into the function. So we substitute 2 into x minus substitute 1 into x. So I continue here. So we have 4 over n pi. So sine n pi 2 divided by 2 minus sine n pi. Substitute 1 is 1 over 2. From this one, 2 and 2 can be cancelled out. Sine n pi is equal to 0. So 0. So 0 minus sine n pi over 2 is negative sine n pi over 2. So 4 over n pi multiply negative sine n pi over 2. So this one, you cannot find the answer because you don't know what is n. If you know the n, hence you can determine the value of sine n pi. Because we have a series, summation from n equal to 1 to infinity, so we just leave our an like this. So this one will be negative 4n pi sine n pi over 2. So we know a naught, we know an, so substitute into the equation. Fx equal to a naught over 2 plus minus, so summation from n equal to 1 to infinity an cos n pi x over 2. So a naught, what is our value of a naught? A naught is 2. So this is our a naught. A naught is 2. So we will have 2 over 2 or equal to 1 plus minus from n equal to 1 to infinity an negative 4 over n pi sine n pi over 2. This is an, so I can put in the bracket. And then lastly, we have cos n pi x over 2. Right, so this is our final answer. To simplify, if you want to simplify, you can put negative 4 over n here. Negative 4 over pi, sorry, you can put outside. So you will have 1 minus 4 over pi. Boleh juga If you don't want, you can just leave your answer like this. So we know this is an, and this is our final answer. Alright, so lastly, we have also Fourier series for odd function. So let's see what is the Fourier series for odd function. Based on the properties of integration of symmetric function, because even an odd function is a symmetric function, so we have a properties of integration of symmetric function. For odd function, the coefficient value of a naught equal to 0, an equal to 0. Why a naught and an equal to 0? This is because the graph is symmetry about origin. So you see this one, see this graph. Let me make it bigger. Okay, so this is one type of odd function. Let's say we have this kind of function where this is odd function. How we know this is odd function? Because this is symmetry on origin. If you flip this graph 2 times, so if I flip here, I get here, and I flip another on the x-axis, I will get this one. So this one, I flip on y-axis, I get here, flip on x-axis, I get here. So this one is odd function. So the properties of integration, we know that the integration mean finding the area under the graph. So if I integrate this area, because this is symmetric, this area is also equal to area of this one on the left hand side, but with negative value because it is under the y-axis. So under y-axis, the area will be negative. So here I get negative a, here I get a. So if I plus these two area, the negative area, negative a plus positive area a, I will get 0. So negative a plus a equal to 0. Hence, an can be 0 and a not also be 0. So for odd function, only bn need to be calculated. So if you have a function which is odd function, if you are required to find a Fourier series, you just need to calculate bn because a naught and an both are 0. So based on the formula of finding Fourier series coefficient, so based on the formula, given that a naught is 1 over L from negative L to L, because an equal to 0 and a naught equal to 0, hence we don't need to find a naught and an because both are equal to 0. For bn, since we know that the area is same, even though one has negative value, one has positive value, but we know that both areas are the same value. So what we need to do is we just find the half of the graph. So because we know that the value of this area, the number here and here are the same, so we just need to find the area from 0 to L only, and then we multiply by 2 so that we can also find the area for this side to this side. So what we need to do is just find from 0 to L only. Hence, we need to modify our function Bn. So Bn is from 0 to L fx sine n pi x over L and multiply by 2. So for odd function, this is only the coefficient you need to find. So you only need to calculate the Bn, where the Bn is 2 over L. And remember, same as even function, rather than we use negative L, so you start here from 0, 0 to L. Fx sine n pi x over L. We know that sine function is the odd function. So we don't need the cos function. Alright, let's proceed to the formula. So instead integrate from negative L to L, we integrate from 0 to L only because the graph is symmetry. And A naught 0, AN 0, and BN is this function. So how to write the formula? So the formula is given as fx equal to summation from n equal to 1 to infinity Bn, where the Bn came from this function. So you substitute Bn sine n pi x over L. So for odd function, this is very easy lah, because you just need to find the value for Bn only. Right, let's see the example number 3. A periodic function fx is given as fx equal to 1 in the range of negative pi over 2 to 0. And it is equal to negative 1 in the range of 0 to pi over 2. And this is periodic function given that the period is pi. That means after pi, the function will repeat itself. So the question is, if fx is odd function, find the Fourier series coefficient. So Fourier series coefficient, what you need to do is, for odd function, just find the Bn and write the corresponding Fourier series. So we are going to copy this one first. So I will copy the image and I will paste on this side. Alright, for A, we need to find the Fourier series coefficient. So we don't need to sketch the graph. But sometimes there are a question asks you to sketch the graph. So if you want to sketch the graph also, can. Let's try to sketch the graph, even though the question doesn't require you to sketch the graph. So I just want to show you what kind of the graph here, so that you are confident this is odd function. So we have the range, here is x, here is fx. So the range is from negative half pi. So here negative pi over 2, here is 0, here is pi over 2. So in the range negative pi over 2 to 0, the function equal to 1. So here is our graph. And in the range of 0 to half pi, negative 1. That means here. Alright, so if you observe this graph, yes, this is a odd function. If I flip here, I will get this one. If I flip here, I also get this one. So the graph is overlap. So this is confirmed odd function. So to find the Fourier series coefficient, first we need to determine the L. So 2L is equal to pi. 2L equal to pi. So you write 2L equal to pi. So L equal to pi divided by 2. So the value of L is pi over 2. A naught is 0. AN also 0. So no need to find A naught and AN. So BN is equal to 2 over L integration 0 to L fx sine n pi x over L with respect to dx. So we are going to integrate with respect to x. Alright, so substitute L. L is pi over 2. So 2 divided by pi over 2 from 0 to pi over 2 fx sine n pi x over pi over 2 dx. Right, so how you want to divide 2 over pi over 2? So you rearrange. So 2 divided pi over 2 is equal to 2 multiply 2 over pi. So from 0 to pi over 2 fx sine n pi x. So divide by pi over 2. So this one same as multiply 2 over pi dx. So pi and pi we cancel. So we have 2 and x. Sine 2 and x. So this one equal to 4 over pi from 0 to pi over 2 fx sine 2 nx dx. Okay. Next, substitute fx. So we are going to integrate from 0 to pi over 2. Look in the graph. From 0 to pi over 2, fx is negative 1. Hence, this one is integration 4 over pi from 0 to pi over 2. Fx is negative 1. So negative 1 I can put here. Negative 1 sine 2 nx dx. Let's copy this one. Copy. Next page. So negative 4 over pi. So integration sine 2 nx. So we get negative cosine. Negative cos 2 nx divided by derivative of 2 nx is 2n. So divide by 2n. From 0 to pi over 2. So 2n is a constant, so I can put outside. So 4 negative 4 over 2n pi. Negative, negative, positive. So will be positive. So cos 2nx from 0 to pi over 2. So I will have 4 divided by 2 is 2. So 2 over n pi cos 2 n pi over 2 minus cos 2n multiply 0. So substitute x. So 2n multiply pi over 2, so will be n pi. So n pi is cos n pi is negative 1 to the power of n minus cos 2n times 0. So cos 0 is 1. So minus 1. Hence, this is our Bn. So Bn is 2 over n pi multiply -1 to the power of n minus 1. So, rewrite our Fourier series for B. Write the Fourier series. So, fx is no a naught. A naught is 0. That means we don't have a naught. So, we just start with summation from n equal to 1 to infinity of Bn sine n by x over, over 2 over L. So summation from n equal to 1 to infinity, Bn is 2 over n pi -1 to the power of n minus 1 sine n pi x over pi over 2. So pi over 2 is 2 over pi, which is 2nx. So I just rewrite this as 2nx. So this is our Fourier series of odd function. So kalau dalam in your notes, please make some correction. Ada salah dalam your notes. Kat mana? Example this one. Okay. Your notes sepatutnya sini sign So potong cross tu tulis sign Cross the cross. In your notes there is some mistake. Right. So this is I think the last example. Example number 4. A periodic function fx is given as fx equal to -3 in the range -2 to -1 equal to x in the range of -1 to 1 and equal to 3 in the range of 1 to 2. Sketch the graph of fx in the range of -2 to 2. Find the Fourier series coefficient and see write the corresponding Fourier series coefficient. So here we need to sketch the graph. So let's copy this one first. Alright, so let's sketch the graph. So I will sketch here. So draw the y and x axis according to the range given. So we need to draw from -2 to 2. So we have 1, 2, 1, 2. So -2, -1, 0, 1, 2. Here is x, here is fx. Don't forget label label x, label fx, and label the axis. So we have -3 and 3. So 1, 2, 3, 1, 2, 3. 1, 2, 3, -1, -2, -3. So in the range -2 to -1 equal to -3. So here, in the range -1 to 1 equal to x. So how you want to plot -x? So if you substitute x, so if I substitute x, -1, fx should be -1. That means here, if I substitute x equal to 0, fx also 0. If I substitute x equal to 1, fx equal to 1. So it is one straight line. Here. And in the range of 1 to 2 equal to 3. So here. Make sure straight line. this is not straight. Let me sketch again. All right. Put this dot line to indicate that this graph from here to here, it jump to here terus -1, it jumps here. Alright, so this is our uh, sketch of the fx. So first let's observe this one, this part on the first quadrant. This is first, second, third, fourth quadrant. So if I flip the graph from this quadrant to second quadrant, so here I will get this one to this one, and from 2 to 4, if I flip, this one will be this line will be this line, so it is overlap. That means this is odd function. So we are going to tell this is odd function because it is symmetry at origin. Symmetry at origin. So this is odd function. So for odd function, if we want to find the Fourier series coefficient, so a naught will be 0, an also 0. So we just need to find the bn. So before we can find bn, let's define L. So we have 2L equal to 2 from this one. So, sorry, 2L equal to 4. So L equal to 4 divided by 2. So L is 2. And then define bn. Bn is 2 over L, integration 0 to L, fx sine n pi x over L dx. So 2 divided by 2, integration from 0 to 2, fx sine n pi x over 2 dx. So looks in the function from 2 to, sorry, from 0 to 2, from 0 to 2. So what is the range? 0 to 2. So here 0 is in this range. So we need to find from 0 to 2, integration from 0 to 2. So 0 is in this range. So 0 to 1, and from 1 to 2. So 0 to 1 is x, 1 to 2 is 3. So substitute in this equation. So 2 divided by 2 is 1. So 0 to 1, x sine n pi x over 2 dx, plus from 1 to 2. From 1 to 2 is 3, kan? 3 sine n pi x over 2 dx. So first, we are going to find the derivative of, integration of x sine n pi x. This one you should obtain directly lah, boleh. Terus 3 you can put outside, and then integration of sine you get negative cos. This one you should use the tabular method. So we are going to solve by using the tabular method. So for tabular method, let's use red color. So differentiate, integrate, differentiate x, integrate sine n pi x over 2. So differentiate x, you get 1. Differentiate 1, you get 0. Sine, you get negative 2 over n pi cos n pi x over 2. And then differentiates again, negative cos, so you get negative sine, negative, negative. So differentiate cos, you get sine. So you have negative sine n pi x over 2 bahagi divide by 2 over n pi. So 2 times 2, negative 4 over n square pi square. So here will be positive, negative, positive, cross multiply here. Alright, so let's write this integration. So first we have x multiply negative 2 over n pi cos n pi x over 2 plus negative 1 multiply negative 4 over n square pi square. So 4 over n square pi square sine n pi x over 2. Alright, so we have finished this integration for this part. So from 0 to 1. So from 0 to 1. Next, this integration. So 3 I can put outside. Put outside 3. So integration of sine n pi, I get negative 2 over n pi cos n pi x over 2 from 1 to 2. Alright, let's substitute negative x, substitute x into this function. Alright, before we substitute, let's observe what happens if I substitute 1. If I substitute 1 into this equation, so here will be 1, here will be 1, 1, 1, here will be 1. So I will get a value lah. But if I substitute 0, here, so here will be 0, 0. So 0 multiply this one is 0. If I substitute 0 here, here also 0. That means 0 plus 0. So I just need to substitute 1. If I substitute 0, this one will be 0. Alright, so let's break down this one. So substitute 1. So I get 1 negative 2 over n pi cos n pi over 2 plus 4 over n square pi square sine n pi over 2. This is substitution of 1. This is for 1. And I substitute 0. So if I substitute 0, so 0, 0, multiply this one. So I want to simplify my writing, because 0 multiply whatever number is 0. So 0 multiply whatever is also 0. So I just write as 0 plus 4 over n square pi square sine 0. This one also should be 0. So 0 plus 0. So I close the bracket. So this one is for this one. Next, for another integration. So 3. Because this is a constant, so I can put constant outside. So let's padam balik ya. Negative 6 over n pi. So this should be more simple lah. If I can put outside all the coefficient. So yang kat dalam will be cos n pi, substitute 2 over 2 minus cos n pi over 2. Alright. So 2 divided by 2. So this one should be negative 1 to the power of n. This one will goes to 0. So let's simplify everything we have. So we have negative 2n pi cos n pi over 2 plus positive 4 over n square pi square sin n pi over 2 minus 0 minus 6 multiply negative 1 to the power of n minus so plus 6 over n pi cos n pi over 2. Alright, so this is my simplification. Alright, so let's observe this one. So here we have negative 2 over n pi cos n pi. Here we can add these together. So negative 2 plus positive 6. So will be 4 over n pi cos n pi over 2. Next, 4 over n square pi square sine n pi over 2 minus 6 negative 1 to the power of n. Right. So from here, we cannot simplify anymore. So this is our Bn. So lastly, Fx. So rewrite this in the Fourier series coefficient. Fourier series. So this is summation from n equal to 1 to infinity Bn. So this is our Bn. So open the big bracket. So 4 over n pi cos n pi over 2 plus 4 over n square pi square sine n pi over 2 minus 6 negative 1 to the power of n. Close the bracket. And don't forget, we have sine n pi x over L. L is 2, so over 2. Alright, that is our final answer. No worries kalau your arrangement tak sama macam saya. Maybe you put this one in front of this one, or maybe this one belakang sekali. It's no worries Make sure the coefficient, all the terms here are correct So we have 3 terms here. Alright, so this is our final answer. So I think we already finished all the example. Okay, so that's it for the chapter number 4. So before we can conclude the chapter number 4, I would like to recap again what we have learned so far in the chapter number 4. So first, you learn to distinguish the even, odd, and neither function. So for even function, this is a recap or summary. Let me rewrite this one as a summary. Summary of chapter number 4. So for number 1, for even function, given that you have fx, so what you need to do is, if you substitute x with negative x, you find that this is same with fx. So this is even function. If I draw the graph, I get the left hand side equal to the right hand side. This is symmetry at y-axis. One of the example. So this is x, this is fx. Or maybe this one. So this is even function. For odd function, number 2, odd function. Given that you have fx, so if you substitute x with negative x, this is equal to negative fx. So if we find the graph, if we try to sketch the graph, you see that our function is symmetry at origin. This one, symmetry at origin. So how to know the graph is symmetry at origin? You flip 2 times. You flip 2 times. You observe that this is overlap. So you flip 2 times. If I flip on the y-axis, I get this one. And then I flip another axis, so I get this one. Or I just flip here first, and then flip again. You also get the same result. So this is symmetry at origin. Number 3, neither function. Given that the function is fx, so if you substitute negative x, this is not equal to fx, also not equal to negative fx. So you get this is neither function. So if you plot the graph, for example, this is fx, this is x, so maybe you get this type of graph. You try to flip 1 time at y-axis or flip 2 times, you also don't get the overlapping graph. So this is a neither function. So after determine the even, odd, and neither function, you determine the Fourier series. Fourier series. So Fourier series, first you need to find the L. Define the L. So from what you need to define the L? Given the periodic x plus 4, for example. So define the L. 2L equal to 4. So L equal to 4 divided by 2. So equal to. And then find the A naught. A naught is 1 over L. Integration from negative L to L fx dx. Find AN. So 1 over L from negative L to L fx cos n pi x over L dx. And lastly, define the Pn. 1 over L from negative L to L fx sine n pi x over L dx. So substitute into the Fourier series. So this is A naught over L. Sorry, A naught over 2 plus summation from n equal to 1 to infinity an cos n pi x over L, Bn sine n pi x over L. Okay, plus an cos n pi x over L plus Bn sine n pi x over L. So this is for Fourier series. Because we have both cos and sine, this should be Fourier series for neither function. Fourier series for even function. Fourier series for even function. So first you determine the L, and then you determine the A naught, where A naught is given as 2 over L from 0 to L fx dx. Determine an 2 over L integration from 0 to L fx cos n pi x over L dx. And lastly, you write the Fourier series as A naught over 2 plus summation from n equal to 1 to infinity an cos n pi x over L. So this is a Fourier series for even function. And lastly, for today's class, so Fourier series for odd function. So a naught is 0, an also 0. So you need to define the L first, and then you need to define the Bn. So Bn is given as 2 over L from 0 to L fx sine n pi x over L dx. Lastly, you write the Fourier series as summation from n equal to 1 to infinity Bn multiply sine n pi x over L. Okay, the important trigonometric function that you should remember. This one are not given in the formula. So there are few things that you need to memorize. First, cos 0. So cos 0 is 1. Next, sine 0. Sine 0 also 0. Cos 0 is 1. Sine 0 is 0. Then cos n pi x. Cos n pi, this is equal to cos negative n pi, where this is equal to negative 1 to the power of n. Sin n pi also equal to sine negative n pi, and this one is 0. So there are 4 trigonometric identities that you must remember in order to complete your Fourier series. So please remember this one. Alright, so I think we have concluded the lesson for chapter number 4. So after this class, I will give you a tutorial for Fourier series. So I hope that you can answer all the questions. There is quite a lot of question. If you have a book, please do the exercise number 5. Kalau kamu ada buku, beli buku, do the exercise number 5. If you don't have the book, I will give you the exercise after this with the answer. So I need you to complete all the exercise and send to me. There are about 15 questions. So I will make it this as compulsory. Please do all the question. Please do all the question if you want to score in this subject. All right. So I think that's all for tonight, for this evening. With that, I conclude our chapter number 4 next week. The same time, 11 o'clock, 11 p.m. a.m. by Google Meet. Then same link. Okay, ada soalan? Alright. Thank you. Assalamualaikum warahmatullahi wabarakatuh.
Thank you, sir.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you, sir.
Okay.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.